In this video, we're going to be going over one of the ways in which we can detect potential outliers called a box plot. But first I want to go into where some of these outliers might be coming from. And one of the most common places that these outliers can be coming from is basically just that we have bad data. And by bad data, I mean that data that's either improperly recorded or improperly gathered. So an example might be broken equipment giving wrong information, or simply just writing down the data that was gathered correctly, writing it down wrong. The second place a lot of outliers can come from is that we're gathering data from a different population. And by this I mean we're just getting data from the wrong source. So maybe if we're trying to analyze the output of a particular machine in a manufacturing plant, we're actually somehow bringing in some of the output from a different machine. And the third one is just a rare event. And this is something that's generally possible but doesn't happen very often. So an example of this might be if you're trying to gather traffic data for a particular city and you're gathering it happens to fall on a national holiday or during a big game, that might kind of skew or give you rare outcomes. Now, the box plot method for detecting outliers is based on the quartiles that we discussed in a previous video. So our quartiles are, we have QU, which is our upper quartile, or the 75th percentile. We have our QM, which is our middle quartile, or 50th percentile, which is also just our median. And we have our QL, which is our lower quartile, or our 25th percentile. And we're going to use this to create what is called an interquartile range. So we're calling this IQR for interquartile range. And our interquartile range is simply the value for our QU minus the value for our QL. So we have QU for Q upper minus QL for Q lower. And remember, the way that we found those was we took our data set and we sorted it and we found the median of our data. So we first found the median, and then we used that median to break our data set into two evenly sized chunks, and then we found the median in both of those. So we found the median for the upper chunk for our QU, and we found the median for our lower chunk for QL. And then our interquartile range is just the distance between our QU and our QL. So basically, how wide is the middle 50% of our data. Now that we have the basic building blocks for our box plot, let's walk through the process of actually constructing one and using it to find potential outliers. So to do that, we're going to need a data set. And the data set that we're going to be using is the weekday exercise time in minutes for 20 male university students. So the first piece that we're going to need to find is the median, or QM, for our data set. And since our data set is 20 individuals, we just need to find the average of the middle two data points. So our middle two data points are 28.5 and 34.5. So we have QM is equal to 28.5 plus 34.5 and divide that by 2. So if we add that together, we get 63 divided by 2. And if we actually do that division, we get 31.5. So our median for our data set is 31.5. Now we need to find our Q upper, or QU, and our Q lower, or QL. So to do that, we're just going to need to find the middle of the two new halves that we have. So for our first one, for Q lower, we're just going to walk through and find the middle of the 9 data points we have here. So that middle would be the 5th point. So we have 1, 2, 3, 4, and 5. So our 0.0 is going to be our Q lower. So we're going to have QL is equal to 0.0. And for our Q upper, we just need to find the middle of these 9 data points. So we have 1, 2, 3, 4, and 5. So we have 78.0 for our Q upper. And the last thing that we talked about was our IQR. So we have our IQR is equal to our Q upper minus our Q lower. So our Q upper is at 78.0 and our Q lower is at 0.0. So if we do 78 minus 0, we just get our interquartile range of 78.0. So now that we have our initial values, we can actually start to build our box plot. So to do that, we're just going to need a y-axis, and we're going to need some ranges. So we're going to go from 0, which our data starts at, up to just about 200. So we're going to have 200 as our max. We're just going to need to put some intervening points in here. We'll put in 100, 150, 50, and dashes for the 25s. And now we can start drawing our actual box plot. So the first thing that we're going to draw is our QM, so that 31.5. So if we go to 31.5, which should be somewhere around here, we're going to draw just a horizontal line to designate where our median value is. And then we're going to draw other horizontal lines for both our QU and our QL. So our QU is at 78.0, so somewhere around here. Just draw another horizontal line, and 0 is our QL, so right about here. And now to draw the actual box for our box plot, we're just going to connect these 3 lines. So draw a vertical line to connect those lines. And we now have our box for our box plot. The next step that we're going to need to do is actually to calculate what are called whiskers. And the whiskers give the name, or the alternative name for our plot, which is called the box and whisker plot. So to calculate where the whiskers go, we're going to need to calculate what are called the inner fences. So the inner fences, we're going to have both an upper inner fence, which we're going to call UIF, and a lower inner fence, which we're going to call LIF. And these are going to be based off the upper quartile and the lower quartile respectively, but also that inner quartile range value. So basically we're going to be trying to be using that inner quartile range value, or the width of the middle 50% of our data, to help us kind of decide where our cutoff point should be for potential outliers. So to do that, we're going to take our quartile values. So for example, we'll calculate the upper inner fence, which is going to be our QU, plus 1.5 times our inner quartile range, or IQR. And for our LIF, or our lower inner fence, we're going to do the same thing. It's going to be our QL, and now we're just going to do minus 1.5 times our IQR. And if we actually calculate those values, we're going to get 0.0 for our lower, minus 1.5 times 78, which is going to give us negative 117. And then for our upper, we have our 78 plus 1.5 times our 78 again, which is going to give us our upper inner fence value of 195. So now that we have our inner fence values, we can draw the whiskers for our box and whisker plot. And to do that, we're just going to draw a vertical line starting at the quartiles out to the most extreme data points inside of our inner fences. So for example, starting from our upper quartile, we're going to draw a vertical line out to the most extreme data point we have inside of our upper inner fence. So if we look at our data, we have a couple of data points that are pretty high. We have this 151.5 and we have this 199.5. Since the 199.5 is outside of our inner fence, we're going to draw our vertical line up to this 151.5, which is now the most extreme data point inside our inner fence of 195. So we're going to find where 151.5 would be, which is somewhere around here. And we're going to draw a vertical line straight down into our box. So this is now the first whisker of our box. And it will actually be the only whisker of our box, so if we were going to draw another vertical line for our lower whisker, we would be starting from our lower quartile value and drawing a vertical line to the most extreme data point on the low end inside of our fence of negative 117. However, we don't have any more lower points below that 0 mark, so we don't have a line for our vertical line here for our whisker. So now that we have our whiskers drawn, we're not quite done yet because we don't really have any ranges for what we're going to consider outliers or suspect or highly suspect outliers. So to get those ranges, we're going to need to calculate 2 more values called our outer fence values. So we're going to have, again, an upper outer fence, which we're going to call UOF, and we're going to have a lower outer fence, which we're going to call LOF. So the formulas for these are very similar to our inner fence formulas. So for our upper outer fence, we're going to have QU plus now 3 times our IQR, And for our lower outer fence, we're going to have QL minus 3 times our IQR. So if we actually calculate those values out, we're going to have, again, our 78 plus 3 times 78, which is going to give us 312. And we're going to have 0 minus 3 times 78, which is going to give us negative 234. So now that we've calculated our outer fence values, we can start designating our potential outliers. And we're going to have two designations for potential outliers. We're going to call it a suspect outlier if it's outside of our inner fence, yet not outside our outer fence, and a highly suspect outlier if it's outside of our outer fence. So for example, on the high side, we have an inner fence of 195 and an outer fence of 312. So we're going to consider any value greater than 195, yet less than 312 as a suspect outlier. So if we look at our data set, we have only one data point that falls within that range. We have our 199.5. And we're going to designate that on our box and whisker plot as simply an asterisk at that 199.5 value. So if we look at that on our chart here, it's going to be right here at the top. We're just going to put an asterisk there to designate that we have a suspect outlier on the high end. And again, if we try to do that on the low end, we don't have any data points that fall between the values of negative 117 and negative 234. If we have any values that fall outside of our outer fence, so anything greater than 312 or less than negative 234, we're going to designate that with another symbol. And this other symbol is generally going to be different according to the software package that you're using to find outliers. So if you're going to be actually drawing these, you can use whatever symbol that you want. Just make sure it's distinguishable between the asterisks and your new symbol. So that's the basics for drawing a box and whisker plot. It basically comes down to we're finding our 3 quartile values, and we're using those values to help give us some potential ranges for what we're going to consider suspect outliers, highly suspect outliers, or just data that generally falls within what we would assume our data set should look like.